subscribe to the channel. And if you are a returning subscriber, subscribe to the channel. And if you are a returning subscriber, remember to like and share with your friends. Okay, so without wasting much time, let's just go for it. I believe by now you have already installed your R and then R Studio. So if you have already installed your R and then R Studio, let's just open the R Studio and then we start today's lecture or today's tutorial. So yeah, so this is my R Studio. This is my R Studio. This is the interface of the R Studio. Now, when you open your R Studio, you will see that we have the interface has been divided into at first glance, you see the interface has been divided into 3. Okay, this area this is where we write anything that we want to write, any code or anything that we want to write. And this is the environment, some kind of memory. So when whatever we are doing will be saved, most of them will be saved in this environment. We can refer to it at any time. And this is our file. So you can open this particular into any other folder that you want. Okay, and you can also access the packages that you have installed. For example, if you click on this one, you will see all other packages that you have. If you also come here, you will see the one that you'll be using a lot is the first one. Okay, this one is what you'll be using. You use to create a script file. You look at it. You look at all of them in a bit. So what we want to do, the first thing is that if, for example, you are in R and then you don't understand anything as this. So this is one way that this particular place, you see, as soon as I hit enter, the result will come and then I will receive another prompt again. Okay, so it's like I can write, I can only be using this short. But if you want to write a longer code and before running it, that is where we utilize the script. Okay, so to create a script, you just need to click on the plus sign over here, and then you see the first one, R script. So just click on it, and then the R script will open for you. So here, this is where you do all other things that you want to do. Okay, so before we even start anything, I want to save this particular script. So I'll just, let me click on Control C and then I'll save it. Maybe let me locate a place I want to save it. Okay, so let me say that. So yeah, so let me save it R programming for you. And the file type automatically will be R because it's a R script. So good. So I've saved it like that and then I can use it. Now I can continue. Now, the first thing that I want to talk about is that R commenting. Okay, I want to talk about commenting. When you are, for example, when you are writing codes or a script, one of the things that you need to focus on most is commenting. Okay, comments, it helps you to make your code readable, and for just as the way in Python and all other we were using comments. So the same thing over here that we do. And in R, to create a comment, we use this. It's just like the way we create comments in the Jupyter notebook. Okay, so I'll see it as a comment, so it doesn't take any code, doesn't see it as a normal code. So that is what you need to take into consideration. Okay, and then here, as I said, this is an R script file, so I can write any other program over here. For example, let me just write my first program. Let me just comment it and say that. So let me see let me just see my first R programming. Okay, so all these things is just an what do you call it? Just a comment. So nothing will really happen. So let me write my first programming, and let me just write my first. Let me see. So let me just name it my first Okay, let me just say my first app. Now, once you do this, we have to assign a variable to that particular thing. And this becomes, we have to assign a value. So this becomes a variable. We'll talk about that one in a little while. So I'm just trying to write my first program, and then I want to write a string. So let me just, and then let me see. Okay. So let me say hello. So hello world. Okay. Okay. Now let me say print. Okay. So let me use my first. Okay. All right. Now, if I select everything, if I want to run this particular thing, so what I will do is I will click on this particular run that we see at the top over here. So once I click on it, now you can see that as soon as you run it, you will see everything running. Okay, you will see everything down here, but the only one that will run is the last one. The only one that will bring outcome is the function for. This is the one that will bring the outcome. Okay, you can see that over here the comments have been run all right, but then it didn't give any output. The same thing, this one has been this one also ran successfully, but it didn't give any output because I just assigned a variable to it, and this is where I'm now calling it. I'm now printing it out with the print function. Okay, I can decide not to use the print function, but then I'll just call it straight away by doing this. My first, okay. So once I only run this thing, it will also give me an answer. Or better say, if I run only this, I can come and call it here. Okay, I can come and call it here and say that over here my first. So once I call it over here, I type my first over here because that is the name of it. It will still give me an answer. Okay, so if the environment here is full and I don't want it, I want to clear it, I just click on this and then it will clear off. So that is just that. That is how we both create our comments and then we create our first script file. Okay. All right. Now, the first thing I want us to talk about is variables. So let me just give some comments. Yeah, I want to do everything in the script. So let me say variable. So the first thing I want to handle is variables. Okay. Now, just as the way we were using in Python, variables are just a storage container. Okay. So we say that variables are a storage container that we install or we store values, data value inside. Okay. So they are just a storage container. It kind of serve as a container where we save our values inside, just as the way we were using in R. Oh, and we are using it R. Whatever that we type in a variable, it creates, as soon as we create a variable, it creates a memory where we can save our values or whatever we want to save, we can save them. Okay, so we say that a variable provides a storage capacity or a storage area that we save our variable or we save our values. Okay, and we have some rules in naming our variable names, just as the way when we in Python we have rules in naming variable names, and we also have the same thing in variable names. Okay, a variable names can be, we start with any character and then ends with either a number or even period or whatever. It can also start with and end with percentage. It can't end with a percentage actually. So when you are naming your variables, you should also be very careful. You can't start a variable name with a number. You can also start a variable name with a period or comma. You can't start a variable name with underscore. Okay. So for example, I can start a variable name like I can say two, maybe two. Like I can write something like this and say this is a variable name. It won't work. It will give me an error. Okay. Automatically, you can see it's giving me. So I can assign a variable using the equal to symbol. So first of all, that is the first one that we can do. The second one is that we can assign a variable using the leftward operator like this. When we talk about, we can create using the less than, and then we put hyphen over there. Okay, and this one too, I can assign it that way. On the other hand, I can also turn it around. I can turn it around, and when I want to turn I want to turn it around with this one. I want to turn it around. I'll write the value first. That is rightward operator. I'll write the value that I want to assign first before writing the variable name. So, for example, let's say I want to assign 10 to a particular number, and then now I'll use the rightward operator like this, and then I'll say this is my var3. Okay, all these are how we can assign variables. Okay, and if I should run any of these, if I should run all these, it should work for me. Okay, once I run it, it will just return the same thing. But right now they are saved in the memory, and you can see them over here. You can see that they are being saved over here like this. We have the var1 with its value. We have the var2. We have the var3 also with the value. So the variable name serves as a storage area where we save our value. You can just look at the variable name as a container, or maybe a save vault where you save your values or you save valuable items. So that is how it is, just as the way it is in Python. So here I can call the variable now. So for example, if I say var1 and I run it, it should return the number that is inside that storage space for me. Okay, so you can see the same thing. Now let me return the var3 just because I've turned it the other way around. Or let me just run all of them. Let me just call them one by one. The var2 also return an answer. Then we have the var3 also returning an answer. So these are how we assign a variable. But the most common ones are the first two. Okay, the most common one that we normally use are the first two. Okay, you can also use the last one, but the most common ones that we use, that is how we say variable. We assign value to variables are the first two. Now, on the other hand, we can also, for example, maybe a group of value, let's say vectors. We talk about vectors later, but we can also assign that. Let's say var4, then I'll say equal to, and I'll save maybe a list of things. Okay, for example, I can say, and with that I'll say C. We'll talk about this later. C, and then maybe 0, 1, or 1, 2, 3, 4. Okay, and then 5, and var5 will be equal to, maybe then I'll type maybe some strings inside. So let me use the word. First one, learn. So learn, then comma. So I want to save this for another things. So here R. Then the next one I'll say maybe programming. Okay. So if I want to run those things that are right, I'll just select them. Okay. I just select. If I also want to run only this particular line, the last line, I don't need to select everything. I can just put the cursor can just be just at the last, the end, and then I'll just click on run. Automatically, it will run only the last one where the cursor is. Okay. So if I want to run this one alone too, the cursor will just be at the end of the code, and then I'll just click on run. Now I've run it. So if I want to run in bulk, that is where I have to select all of them. Okay, if I want to run all of them together, that's where I have to. So now if I call var4, it should give me things that were saved in var4. Okay, and if I call var5, it should give me things that were saved in it. Okay, so this is how we use variables in R. So that is it. Now let's talk about the print statements over here. If at first, when I was doing my first R programming, I used a print statement. Now let's look at the print statement very well. Once that we write so many other things, we can just print together. Okay, we can just print var. We can print the first, and maybe I say that I'll say I'll put in quote, I'll say the value of var. So let me say maybe the value of var2 is, then I'll just put a colon. Maybe I want, that is how I want to, let me just do it this way, and then say, let me put some space here so that, and then comma, then I'll now call var2. Okay, so once I call var2, I can just run it. Okay, so let me just run these two print statements, and let's see what happens. Good. var1 not found. Okay, it means that I have to rerun the var1. So let me run everything over here. Good. So if I run this, I should get object var1 not found. This is my var1. So it's telling me that object var1 not found. Let me see. Okay. Okay, let me just run the last one and see what. Okay, so you see when I run the last one, which is the cat, when I run the cat one, you see how it appears. First of all, you have an information in front of it. We have something. It says that the value of var2 is, before it display the value of var2. Okay, so that is how it is. Now let me type over here and see var1. So the var1, when you print it here, it's working, but I don't know why here it's not running. Object var1 not found. The value of var1 is here. Okay, you look at that one in a bit. So these are the two ways that you can actually print your variables outside when you want to use either the print or the, because when we use the print here, it's working. So let me see, print var3, and you have the answer. So let me change the values here and see. Good. So now it's working. Now when I change it to var3, the print function, this one is working. Okay, so yes, you can change it to any other. You can change it to maybe, okay, let me print var4. So once I change it to, it prints out this thing, the value over here. Okay, but if I want to decorate it, I want to maybe display something first. That is where I can use the cat to do the printing. All right, so that is about the variables and how we assign them. Okay, that's how we assign variables in them. Yeah. Now we have, for example, we can find variables where if you, to know the variables current available in a particular workspace, we can use the ls function also, which help us use find the variables that are inside our directory. So for example, if I type something like this, if I type ls and then I open and close parentheses and I run, it should tell me, it should give me the name of all the variables inside my directory. Okay, it should give me the name of all the variables that have been saved here. Okay, when it comes to all the variables that have been saved here, that and you can see the first one is my first, the next one is var1, var2, var3, var4, var5. So that is how if you want to find out the variables inside your directory, that is how we use this ls to find them. Okay, there is another thing that we should look at under variables, is how we can delete a variable. For example, if we want to delete particular variables we use the delete the first variable, that is var1. So what I will do is that I'll use the rm, okay, and then I'll open my parentheses, and now I'll type in the variable that I want to delete. Okay, so var1, I want to remove var1 from my directory. Okay, so once I run this, so it's giving me a warning, object var1 not found. So right now it will remove the var1 from, if I'm searching for var1 again, I won't get it. Okay, I'm getting it. So let me see. Let me try to remove it from here. So rm, and then maybe, so let me try var2 and then run it. Okay, so automatically as soon as I run it, it removed the var2. Now you can see that the var2 is off. Rm, and then maybe var1, object var1 not found. it's not locating my var1, but that is how you remove variables. Okay, now you can see that right now I've removed variable 1 variable 2 from it. So if I try to access variable 2 again, var2, if I type var2 here, there is no object found. Okay, it can't be found anywhere. So it means that that is how we remove variables. So let me comment it. Removing. So that is how we remove variables from our directory. If you want to remove any variable, as soon as you do that, you have to know that as soon as you do that, it will be removed. You can't see it anywhere. You can't find it. So that is how we remove our variables. All right. So the next thing that we will look at is, I will try to look at some data structures. Okay, we look at some data structure, basically some data structure. And the first one that we look at is vectors. So we have vectors. So we say that vectors. And how do we create vector? We say that a vector is a continuous collection of objects of the same type. Okay, it's a continuous collection of objects of the same type. And then we have common types of vectors. We have some like the logical, the integers, the double, the character. Like in fact, you can combine all of them to form a vector. And how we create a vector is we use the C function. Okay, for example, when you see over here, I was trying to use, and when I was creating this particular variable, I used the C function. So basically, that's how we create a vector. For you to create any particular vector, we use the C function to create them. And once you use your C, then you can type in anything that you want to do. If it could be for example, it could be numbers, that is numerical, integers, characters, strings, or whatever. Okay, so you can actually create a vector. And when you create a vector, mostly we assign it to a variable. So we create a variable which becomes the memory or a storage area where we save our vector. So let's say that I want to create a particular vector. Let me just say that I want to create a vector like, okay, let me say apple. Okay, so let me just say apple, and then I just want to assign some certain things to okay, let me start with a simple one first by using x, and then I'll save some values to this particular x. Now you can either use this, the leftward operator, or the equal to, any of them that works for you, any of them that you are okay with. You can use it. So let me use x and then assign some value. So let me say 3, 2, 5, 6, and then maybe something like 56. Okay, so once I do this, and I've created a vector, when I run it, I can access it. It means that as soon as I run it, I'm creating a space and that space, the name of that storage is X, and I'm saving these particular values inside that particular space. So that is what I'm doing. Similarly, I can also create another one. Let's say Y, and this time around I'll create like C, and then I'll create maybe some characters inside, and they all be characters. So A, then I'll come out comma, and then B, comma, C, comma, then maybe M. So so once I do all this, I can run both of them, and as soon as I run it, I can access them over here. I can access them as soon as when I type X, it should give me the values that are stored in X. If I also type Y, it should give me the values that are stored. So you can see that this is actually a character values, and kind of they have been saved in quotes. So that is how we create variable. We can create so many other things out of the variable. So let me just create some, maybe another variable, and I'll name it like colors. Okay, so let me just say colors, and then out. So the first one is maybe red, and then I'll create another one blue. Okay, and then maybe yellow. So now I can run this. So I run this, and then as soon as I call colors over here, so as soon as I call colors and run it, it should give me the values that have been saved inside the colors variable. So that is how we create variables. That's how we create variables. Another thing we will look at is another data structure that we will look at is list. Okay, so we say that a list, a list, a list is all kind of it's a kind of object that we put together. Okay, so we put all of them together, and we say they differ in different types. Like you can actually use different types. And as for a list, you can even put your vectors inside. Okay, so we say that a list is an R object which can contain many different types of elements. So it's an object that contains different types of elements inside. Okay, so one of the ways that we can create a list is that, so let me give a comment and say list. So, and then I'll clean this side. So with this, so I'll create a first list maybe, and we use the keyword list. We use the word list to create a list. So let me just say that, let me just name it as my first list. So my first list, and I'll assign it, and I'll use the word list. Okay, as soon as you use the word, you type list, you put it in brackets, then you can as well. So it puts them in accordance, it put them down line by line, because we actually created them as kind of a list. It break them together for us. So that is how we create a list. Okay, so that is about a list. Now we also have metrics, and with metrics, just as the way we create a normal metrics, just as we know about normal metrics, it can be either a 2 by 2 or 3 by 3, or whatever way you want to create it, whatever way you want it. It can actually take any other form. Okay, but we also use, to create a metric, we use the keyword metrics. Okay, so because it's a metric is a two-dimensional data structure in R, just as similar as the vector. Matrix must contain objects of the same type. Okay, so when you are creating matrix, you have to make sure that it contains objects of the same type. You can't mix different type. When I say different type, you can't mix like maybe character values, a string to maybe numbers. You can't mix them together. So that is how we work about metrics. Okay, all right. So let's look at how we can create a matrix. So my matrix is, then I'll use the word matrix. Okay, so when the first thing that appears is that when you are there, we have the first one, which is the data. Okay, so you give the data. Once you use the keyword matrix, the first parameter that the matrix function takes is that the data. Okay, the data. And then the second one is the number of rows that you want. The second is the number of columns that you want. Okay, and then you can either specify the whether by rows or by columns. Okay, so when you see the by row, it means that you are actually making the matrix to be in kind of to read in rows form. Okay, so if you specify the by row is equal to true, it means that the matrix is actually going to the numbers that you specify. It will count in rows form. So let's assume that we have this kind of numbers. So inside, let me create a vector inside. So the vectors, I'll say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so once I create, so that become my data. And then the next one will be that I'll type n row. Okay, so n row equals, how many rows do I want? I want it to be 3 rows. And then the next one is I'll use the n column, that is NCCOL. Okay, so and that one too, I want it by 3. And the next one will be, the next argument will be by row. Okay, so I'll use the by row format. The by row, so the by row here is either I specify false or true. Okay, so let's use the true first. Let's say that we say by row is true. Okay, so let's say it's true, and then we are done. Then let's run it and see what we are going to get. So now our matrix has run successfully. So let's call the matrix. The name of the variable is my matrix. So I'll say my, okay, let me clear the environment and rerun it again so that you can see it clearly. So we have this, my matrix. Good. So now this is our matrix. This is our matrix string. So I say by row, and you can see that the by row is reading like this. It will start 1, 2, 3 before it stop, because I say the row should be the column should be 3. It will read 3 times. Then before it continue again. So this becomes the next 3 becomes the next row, and then the next 3 also become the next row. Okay, now let's copy the same thing. Okay, and then go down and paste it. But this time around, let's see my matrix 2. Okay, and let's run it. And now let's call my matrix 2. Okay, so my matrix 2 now with, oh sorry, I wanted us to change this one to false. So good, so let's change it to false rather. So I want us to change it to false, then we see what happened. Good. So now when I change my matrix 2 to, when I change the by row to false, look at how it works. It's actually working in column direction. Okay, so it's working like this. So I have numbers ranging from somewhere 1, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the numbers I have. and then I'm creating a matrix out of it, and I say that the row, the n row should be equal to 3, and then the n column should also be equal to 3. So what this means is that I'm saying that create a matrix of 3 by 3, okay? So create a matrix of 3 by 3 for me. 3 columns, 3 rows, okay? That is 3 rows, 3 columns. So create a matrix of 3 rows, 3 columns for me. Now, when you are done, the first one, the first argument, the last argument, which I say by row is equal to true. So the by row is equal to true, it signifies that, okay, create a matrix in such a way that it will read in row 4, okay? So when you start using the numbers that I'll specify here to create the matrix, do it this way. Do it in row wise. So I will say that it will start at 1, 2, 3, and then it will stop. It has created 3 columns, okay? So it will stop. Then it will now move to the next column again and continue 4, 5, 6, and stop. 7, 8, 9. So the by row is equal to 3. That is how it reads, okay? But when we say that by row is equal to 4, 6, and then move to the next one again. 7, 8, 6, and then move to the next one again. 7, 8, 9. So this is how the by row is equal to 4 work, okay? Whilst the by row is equal to 3, is equal to true. This is how it works. So these are how the two difference work together, okay? So this is how the two difference work. So let's move on. So that's how we create matrix. Now let's also try to create another matrix. You can actually create matrix not only with the numbers or values, okay? You can actually create matrix with even characters. So for example, maybe I can say that my matrix 3, and then I'll assign it to something like this. So I'll say matrix, and inside I'll use some values, maybe ABC. So say A, but because it's character value, always remember to put it in quotes. So A, then I'll say, let me specify another A, and maybe B, and then let me use CBA again. So C, B, A. Okay, so I have 1, 2, 3, 4, 5, 6. Good. So because it's 6, I can get 2 by 3 matrix out of it. So now I have these two. I've already gotten my data. So the next thing I have to specify is the row. So I'll say n row is equal to the n row over here. I'll specify maybe I want 2 rows. Okay. If I want 2 rows, let me just say I want 2 rows, and then n column. With the n column, let's say the column, because it's a 6 character values over here. If I choose 2 rows, okay, then it means that definitely the next will have to be 3 rows, 3 columns. So n column is 3, and that maybe let me make by row. By row should be true for me. Okay, so my by row is actually true. So right now I can't run it, but let me call it out. So let me see print my matrix 3, and then let me select everything and run. Good. So as soon as I run it, I'm now having 2 by this particular 2 rows, 3 columns. And when you look at it, you can see that at the top of it we have some numbers, but each of the numbers are comma 1, comma 2, comma 3, and then down here we are having 1 comma. So what this means is that we can actually access this particular metrics by their positions. Okay, so we can access those metrics by their positions. So this is how it is. We have let's say I have 1, 2, 3, and then 4, 5, 6, 7, 8, 9. Okay, and on top of this one I have something like this, comma 1, then this one, comma 2, and this one I have comma 3. And when you come to this particular side, it's like 1, comma, then close. Then you have 2, comma, then you have 3, comma. What this is doing is that I can use these ones to access the elements inside a particular matrix. So if I want this one, if I want this particular value, its positions are that is the 1, 1. So it means I can use the bracket like this, 1. I can use the 1 and 1 to access it. Okay, so when I use the 1 and 1, that is this one and this one, I will access this particular matrix. So if I want this particular matrix too, I'll use this position and this position. So it means that this position is referencing the whole of this one. This one is also referencing this. This one is referencing, and this one is also referencing this downward. This one downward, this one downwards, like that. So that is how we can also access the individual metrics inside. Okay, so you can use those positions to access each of the metrics inside. Okay, so that is about metrics. That is about matrices in R. Okay, the next we want to look at is arrays. Okay, so let's look at arrays in R. Okay, you see that the in R just as the way we were using arrays in Python, we can also use arrays in metrics. R as well. Okay, and we can create just a list out of it, which we can actually, just like a matrix, we can create it just like a matrix and have the dimension that a matrix have. Okay, so we can also use it that way, just the same thing. So you see that array can be of any number of dimensions. It can be of any number of dimensions. Okay, while metrics are confined to 2 dimensions, arrays are not like that, because metrics are for 2 dimensions, but arrays are not like that. Arrays can be of any dimension at all. So you can create an array of any dimension at all in R. So let's just try to create some array of certain dimension. So let's say that A, and then I'll assign it to a value like this. And then I'll use the array keyword to create it. And inside, I want to create some vectors inside. And the first one I want to use, so let me say green. Okay, and then let me use red. So these 2 one. And now the next I want to do is that, you see, as soon as you specify the data, it's asking of the dimension, that is the length of the length of the array that you want to create. Okay, now I want to create maybe a dimension of 3 by 3 by 2, some kind of like that. Unlike the metrics where you have, if you want it to be 3 by 3 or 3 by 2 or 2 by 1, with the array it can be of any other dimensions. Okay, so I can be like 3 by 3 by 2. Okay, so let me specify dimension, and with the dimension I'll say dim. I'll use the word dim. So as soon as I say dim, I'll say equal to, and then I want to create a dimension of something like this, 3, then 3, then 2. So let me create this, and I'll run. Let me run this. So let me now call my A, and then you see the outcome. Good. So you can see that it has created a 3 by 3 matrix for me, but then it has created it in 2. Okay, it has created it twice. Okay, so what the dimension, this one is given that, okay, let it be a 3 by 3. The first two is specified that create a 3 by 3 array for me, but make sure you create it twice. Okay, so you create it 2 times. So it creates the first one and then it also creates the second one, and it's random. It just gets the same as the first one. Okay, so if you look at it, first of all, it starts with green, red, green. Then it come back red, green, red, green, red, green. So one is done, that the next one that it will start with, it's now red, green, red, green, red, green, and then red, green, red. So it kind of it mix it up. It finish it and then start with the next one again. So it continue that way. So this is how we create arrays um, in R. Okay, with array, it's unlike the matrix where it has a two dimension. The arrays doesn't have that. It's more than that of the matrix. So the array it takes the dimension attributes, which creates the required number of dimensions. Okay, so the dim function, that is the dimension function attribute, the one that creates the required attribute that we want. Okay, factors. So for example, factors. So for example, let's create a particular vector that we have. Okay, we already have some vectors inside here. So we have some vectors over here. So like a vector like colors. So let me just turn it to factors. Okay, so I will say that, so factors, and then I will say that my factor, and then I'll use the word factor. Okay, so I'll use the word factor, and then I'll pass on the colors. Okay, because I've already created that one as a vector, I'll just pass on that particular one, and then let me run it. So now if I call out my tabular data object, so when you create something, it turns it to a table for you, create it kind of a table for you where you can easily access at any time. So let's try to just create a sample of them. And the way we do it is that we use the keyword data.frame. Okay, we use the data.frame and then for you to create it. So let me comment and say that data, so data frame, and then so data first one. The next one is maybe I want to mail again. So, and then the last one, another mail. Okay, so once I'm done with the first column, so I'm creating it in a column wise. So as soon as I specify this one, it means that this is column 1. Okay, and then I'll give a comma. Then I'll move on to the next column again. So I'll move on to the next column. So let me say that this thing, okay, let me try to create it this way so that it makes sense. So the first one is name. So I will say name, and then I'll assign some name. And then, so the first one is that. So I have John, and then so Jones, and then another mail again. So this time around, we have Rich. So, and then I'll give comma, and I have a gender. And the next one is that maybe I want to specify their age. So age, then I'll give this like this. This time around, maybe 23 and 30, and then 35. They are 4, so everything should be in that order because they are 4. You should make sure that they all align. So I have another 4, and then maybe this one is 20. So let me close it, let me give a comma, and then let me create maybe weight. So this one is weight. So, and this time around I want to specify their weight. We have something like maybe 68. So just 81, 70, maybe 72. Okay, so I think this is enough. This is okay. So once I run this, I have a data frame created for me, and it's a tabular form. So right now, if I called my data frame, if I said that my data frame, okay. So now one thing in R is that as soon as you create a data frame, okay, as soon as you create a data frame and you start typing the name of the data frame, you will see the table. It will create a table for you. You see how it will be arrayed. So with that, that is one thing I like about R. Okay, with this I already know the column. For example, if it's a big data I'm trying to access, I'm trying to work with, and then I don't know the names of the columns. As soon as I start typing the name of the data, it will give me the names, it will give me how the data look like, and then I'll see what is inside. Okay, so with this I already know how the data frame look like. So these are the data. You can see the first name John, and then I assign the gender as male, the age 23, the weight, then I have the rows, same thing, John, Rich. Okay, so even if I click OK and then I hit enter, now you can see that it's being you can see how it's being specified. So over here we have the heading as name, gender, weight, and then we have for the name we have the what is written inside, that of the female, the gender, the age and stuff. So this is how the data framework. Even if it is a CSV file, comma separated files, you can actually turn it to a data frame where you create a table out of it. Just like the way we were using Python to create a data frame, a table out of our data set. The same thing as R, okay? So R is very powerful that you can use to also do all this work, okay? So let's try to create another data frame and see how that one also works. So that is just that about a data frame. Okay, so let's create another one. Okay, let's create another one, and this time around let me say that let me use the keyword df and then just assign it to, so data dot frame, and then the first thing I want to specify is that I want to specify the column. So this time around, so let me open it this way, and then the column, let's say I want to specify the hair color of some people. So I'll say hair color. So that's the name of the column, and then I'll create a vector. The vector, I'll have the colors. So I have red, and then maybe black, then black, maybe I have like some kind of, so there's some kind of color like yeah, and then I think this is okay. And then the next one is that the eye color. Okay, I have the hair color, so let me specify the eye color. So so maybe I've heard we have brown eyes, so let me use brown, type brown, and then yeah, let me just maybe color like blue. Okay, although I've not seen some before, but it's just a fictional data, don't worry. Yeah. And then maybe another age, and then I'll say with this it's an integer, so I have something like 22, maybe 23, and this time okay. So now what I want to do is that I want to do something like I want to create something and ask whether they have either a degree or they don't. Okay, so with a degree, let me say okay, let me say that whether they have MSc. So MSc, that is masters, they have MSc or not. So this time with this one, what I will do is that I'll use a Boolean function, and with the Boolean functions I'll try to use the true or false. Okay, so let's say the first one, the person is true, though I'll use the second one, the person is also is false, and then the last one is true because it's only 3. And then let me just run this. Okay, so now down here, let me say df, let me call the df, and then I'll run everything together. So let me clear the environment. Okay, and then now let's run it. Okay, so now when we run it, you can see that it has created a data frame for us. Now when you come to the MSc, the master's column, you will see that I was using the character T, F, and T, but I'll understand that okay, with when I'm creating a vector of TF, I'm using T and F, it automatically recognizes that is actually either true or false. Okay, so it recognizes that it's either true or false. So that is what we are doing. So it creates a nice vector for us over here. At any point in time, if I try to call the name of that data frame, if I say df, if I try to call that df, it should be able to give me display the data frame over here. Okay, when you come to our environment, you should see that data frame has been created and it's at the top over here. So with the data frame, you see that it make it like this. Is that a data frame or a list? Okay? And I can click on it to open it. So when I click on it, it will open here, and you can now see that table very clearly. Okay, even the first one that we created, when I click on it, that one too, you will see it over here. So we have the John, Rose, Jones, Rich, and the df2 it creates, and then this is it has created a table for us over here. So that is how we create a data frame in R. Okay. Okay. So I hope everyone is following. Okay. So that is about the data frame as well. Okay. The next thing that I will talk about is that since we've already talked about variables and data frame, so the next thing that I want to talk about is we want to talk about the data type. Okay, now we have some data types in R. Okay, so basically R has some the common data type that we have is they are actually we have some common ones, and those common ones are the numeric data type. We have the integer data type, the complex data type, the character, and then the logical data type. Okay, so let's just look at how all of them are. There, if you hear it, you the integer and then the data type, the numeric data type are kind of a bit different. Okay, with I will start with the logical. With the logical data type is the true or false. Okay, so let me give a comment and say data types, and then the first one is the logical. Okay, so we have the first one. We have the first one as we have the logical. Okay, the logical data type. Yeah, the logical data type is actually the boolean. Okay, it is, so let me say into brackets boolean. You have the boolean. it's boolean, that is the true or false. Okay, so that is the true or false of the data type. So for example, let me assign some variable. Let me say that v, let me assign v to, and then I'll type true. Okay, so let me type true. And the next thing is that I want to see the class. Now if you want to access use the class data, you use the class function to determine which data type we are using. Okay, so let me run this, and then I'll access it from the environment. So inside the environment over here, I will say that class. So I'll use the class and then the v, because I save it as v. So I'll say class v, and then let me see the data type of v. Automatically, you see that as soon as I run it, it will indicate logical. Okay, it indicates that the true is a logical data type. Okay, so this make it that is how we access the data type, and that is the first one. The next data type that we know is that the next data type is the numeric data type. So we have the numeric, data type. So the numeric data type, with the numeric data type, these are the values that are just the ordinary numbers. We have 1, 2, 3, 2.3, and all the other stuff. Okay, so that is the kind of numeric data type that we have. So with that one, it's just like 10.5, 55, 25. So those are the numeric data type. So for example, if I assign a value like maybe t, so t, and then I assign something like 12.5, okay, if I assign something like this, and I come to the environment, I run it, and then let me run this and come here. If I check the class of t, it should tell me that it's numeric. Okay, so that is how we are also the numeric. So when I use the integer data type and I say maybe k, I'm assigning a value to k, and I say that this is 33L. Okay, as soon as I do this and I run this, when I run this and I access it by class k, it should tell me that this is an integer data type. Okay, so it's showing that this is an integer data type. So that is about the integer data type. The next data type that we want to talk about is the complex data type. With the complex data type, it's specified by the imaginary part. You know, with a complex number is being represented as, we have, for example, if I have a complex number, it's being represented as a plus bi, okay, where this part is the imaginary, okay, where this part is the imaginary part of it. Okay, so we have the whole number part and then the imaginary part that signifies as the complex. So the complex data type, it's always like, for example, I can have 3 plus maybe 2i, where this signifies the imaginary part of the data, this particular one. So I can also check it like this. So let me assign something like r, then I will say that this is maybe 3 plus 5i. Okay, so if I run this and then value, okay, so let me assign some group of value to this particular one, and I'll put it in quote. So I say hello. So let me say hello. And if I run this, and then I come back down here and I say that, hey, class kill, it should tell me that that is a character. So it's showing that yes, that is a character data type. Okay. So that is about how we also access the data type, character, and all other in R. The next part that we want to look at is the operators, that is operators in R, how we can use operators. Okay. For example, just as the way we have operators in R, we have the addition, the subtractions, multiplications, and even the logical operators, where we have either uh, the or and the and operators. So those are the things that we want to look at right now. We will have to look at the arithmetic operators, that is the maths operators, the relationship operators, the logical operators, and then the assignment operator. So let's first of all look at the addition operators. Okay, with the addition operator, that one is just as usual. Is we have the plus, which we can use to add two vectors or two numbers together. Okay, so we can use it to add two numbers or two vectors together. Okay, so let's look at them. See, so let me create two vectors. Let me say t, and then I want to create a vector of numbers. Okay, so this time around, let me create 2, 3, 4.2, okay, 4.3, and then let me say 6. So that is the first one, and then the next one, w. So let me create another vector, and 8, 3, 4. Okay, so if I run these two, and then I can create addition out of it. So for example, let me say print, okay, let me say print, and then I will say that print t plus w. What will happen is that it will take this, and then it will add it this way. It will take the first ones and add them, take the second one, add them, take the last one and add them. That is how it creates them, and create for the first one as well. So we have something like, for example, the multiplications. I can say print so yeah, I'll say print, and then this time around I'll say t multiplied by w and run it. And when I run it, it should multiply each of them in that order for me. So that is how we do that. Similarly, we can do the division too, and with the division we just put it just the same way. We use the, so I'll say t divided by w, and this one will also do the division as that for me. We are dividing the 2 by 8. Okay, we are dividing the 2 by 8, but it's giving us that, okay, when we divide the 2 by 8, what are we getting? When we also come here, we divide the 6 by 4, what do you get? So it's divide it and return only the remainder. Okay, it's check it how many times when it divides, what will be the remainder of it, and that is what it actually returned for us. Okay, on the other hand, if we put for if you put the backslash inside, okay, when you put the backslash inside, that one it will render of it. So when you look at it, when the 8 we divide, we are trying to actually divide the so let me call it like it return the quotient, okay, it return the quotient of our division. So the result of the division of the first vector with the second one, then it will return produce the quotient of our answer for us. That is, it will always give us the 0 1 1, okay. So that is what it's actually returning for us, okay. Now the next operator that we also want to look at is actually we want to look at the relation operators. With the relation operators, they are those operators that are less than, greater than, and then equal to. For example, because we have the first equal to as assignment operator, okay, we have something like this. We have the relation operators are, we have the less than, greater than, okay. We also have the equal to. The equal to is given by 2 equal sign, okay, because the first only one equal sign is assignment. It means that assignment operator. So the equal to is given by 2 equal to sign like this. And then we have the greater than or less than, okay. We have the less than or equal to, we have the greater than or equal to, just like this way. And these are all relation operators, okay, to check the relationship between two things. The other ones, the element-wise logical operators. So this one is the element-wise logical operators, where we can use to either check whether two things are true. It combine two things. So we have two vectors, it will combine them together and check which, if they are true. It always return a boolean, which is the true or false for us. We also have the element-wise logical or operator, okay. We have the element-wise logical operator, which is the other way around. We have this as, so this becomes the element-wise logical operator for us. So that is how the two of them work. So let's just see example of them. Let's see example of them and see how they work. So let's create a vector. So let's create a vector. And then the vector that we want to create something like maybe we have G. I want to assign G to something like C. So I'll say 3, and then 1, I'll fuse it with maybe true, okay, and then this is it's okay. And then the next one is H, and I'll create another vector where this one I'll say 4, 2, and I'll use the word force, okay. So if I print, if I say print, and then I say it should print G, let's move on. I believe then the audio is very okay now. Okay, so let's continue. So that is about the element-wise or end, the element-wise end. With the or, it's like once one is true, it will return a true answer. So you just consider only one. But with the end, the element-wise logical end operator, it's like both sides must be true before it return an answer. Once one is wrong, it won't accept it. To say it will return a false for that particular one. Okay. So that is about this one as well. Okay. Now, aside the element-wise logical operators, we also have the ordinary, that is the logical operators, okay, which we have the logical and then the logical or operators. With those ones, that what we do is that we actually should add the two of them together. So, for example, in this case, this one is going to be 2. Okay, this one is going to be 2, and when you come here, this one will be also be 2. So that is how the other one work. So this is the logical. Okay. Okay. So it's given, I said that's what error in G and H. Okay, length is equal 3 in correction to logical one. Okay. So let me give another one. So let me say that another one. So one. So let me update this value. Okay, so let me just type this over here and see what it will return. Okay, so let me say so let me just give it good. All right, but when you give it 1 1, it will actually return the answer for you. Okay, so maybe let me say this one, and so in this case let me specify maybe a character value. Okay, so invalid y type. Okay, it's a data type. So you can see that as soon as I combine the two of them, which is the with numeric and character, it's giving me as error. The reason being that the invalid data type, we don't have the data type are not the same. Okay, so it can actually return that answer as well. But that is how the two of them work. Okay, all right. So as I've already assignment operators, we won't waste much time on the assignment operators. With the assignment operators, we have basically like we look at 3 of them where you have the one equal to the leftward assignment operator and the right assignment operator, which we can all use all of them together. So for example, you can either use any of them to work. When you the first one is the normal equal to, and then we have the leftward operator, and we also have the rightward operator. So all of them are all assignment operated, and you can use all of them at any point in time, and they will all work for you. So that is about the assignment operator. Okay. All right. Now let's talk about conditional statements. Okay. The first conditional statement we want to talk about is the if statement. Okay. With the if statement, just as the way we have the if statement in Python, we also have it in R as well. So let me specify this area. Comment if statement. All right. So you have the if statement. With the if statement, first of all, we give a condition, and then the conditions, it checks whether the condition is true. When the condition is true, it's return or run the code for us. If the condition is false, it's also return another thing as well. Okay, so if we give a particular conditions, it's move on inside and then return the condition code. Okay, but the one that is false, it just leave our loop. So for example, we have a if we have a what do you call it, a condition like this. So it's like the first rule is that, oh okay, so this is my code, it's move on and check the condition I give. So the condition is here. So you check if this condition is true. If this condition is true, it's move on to execute the code for me. So the condition code, so this is the condition code, and then bring out the results. So it's bring out the results. But if this was, so this is if true. So if false, it just move out of the loop. Okay, it just move out of the statement. So if false, then it just move out. So first of all, you check the condition. As any point in time the condition is true, it executes my statement that I give. But if you check and realize that, hey, the condition that you've given is false, it just leave out of the loop. So for example, let me just write one and let's see what happens. So let's say that we have a condition. So let's say the first one is that we are trying to assign a particular value, and then we say that, oh okay, hey, we have our x to be equal to something like this. Let me use this. We have s is equal to, and then we say 30l. Okay, so integer. So now we have assigned a value to a particular variable. So we say if, that we open our parentheses and now start to. Right. So now what I want to check is, I want to check if a statement. So if, and then inside the if, I will indicate the statement. What do I want to do? So check something for me. And this time around, because I've assigned a value, an integer value to x, I will say that is dot integer. I want to check when I'm trying to use this, I'm trying to check if this is truly an integer. Okay, so and inside the integer, I'll say that, okay, check if x is an integer, and then I'll come out and open I'll open a parenthesis like this, and now I'll now write my statement. Okay, so this is the condition. This is the condition. Check it for me. If the condition is true, print out something for me. Okay, so here I'll say that print, and then inside I'll indicate that, I will say that, so I'll say x, so maybe x is an integer. So let me say x is an integer. Okay, so let me just run it. Okay, so as soon as I run it, it's checked. Once it is true, it will print x is an integer. Okay, once it is true, it will print out x is an integer, and you can see that it have printed out x is an integer. Okay, so if the condition is not true, it will just jump out. Okay, now let's improve this code. That is where, if you want to move a bit further away, that is where we have the if else statement. Okay, so we have the if else. We first of all start with the if, then the next one is the if else, and then the next one is the else statement. Okay, so this is how it moves on. So this is how it's continued to move on. So let's look at where we can use the if else. Okay, we can continue with the if else. With the if else, let's try to look at a flow chart. Let's look at how that one also works. Okay, so first of all, it starts like this. So let me just start it this way, and then, so this is my condition. So I have the condition here. So I have the conditions, and then it just move out like this. So if the condition is true, so if true, then come and execute this code for me. Okay, so if true, then if code. So if this particular condition is true, come and execute this code for me, this conditional code for me. Okay, let me just assign a different value to x, and I said 55. So now I'll come and say if, so if, then I'll ask a particular thing. Okay, so here, just as the same way we have the other one, so I'll say that if x greater than, okay, so if x greater than, this particular statement, so I'm intentionally specifying a bigger value. So I'll say if x is greater than 100, then print out something for me. So print, so what do I want to print? If you check and then x is greater than 100, okay, print sounds come to work, okay, which means that the first statement was not true. Now we can also combine, and we have the if else statement. That is the if else and then if else statement. Okay, in this one, what we do is that we give the first condition. So if the condition is true, execute something else. If else, go and print another thing. If that one too is not true, go and print another thing. Okay, so it continues like that till it comes out. So let's write one and say, so let's write another one here. Let's say that, so let's say here it's if else if, so if else statement. So we are actually combining two things together. So here I'll say that I want to assign a variable to s, and I'll say something like this. So here I'll give some keywords. So what, then is, and then, so let me see, truth, and then those are the valid characters, vector I have assigned to us. And then now I'll use this and I'll say so truth, so you have truth, so I'll say truth. I want to check if the keyword truth is actually in x. So to do that, I'll use this thing. I'll say that in x, then I'll now open my, so I'll do this, and then the first thing I'll print, I'll say print, okay, so in x, then what do I want to print? I want to print, so what I want to print out is that I'll say truth. So truth is found the second time. Truth is found the second time. And now the next one I want to give is, I want to say else. Okay, else. And with the else, I won't give you the condition again. I'll just print out something. So it's like the first one is checking condition, the second one is checking condition, the last one is not checking out any condition. It's just print out the results. Okay, just print out something else. If the first, all the conditions above were not met, then do out something for me. So over here, I'll just print out. I'll just say print. So I'll just say print, and then I'll say no. Okay, no truth. So no truth found. Okay, so this is enough. So now the first condition, this if the truth is found. Now you notice that the case are not the same. We have the what do you call it? The first truth is actually with small letters, but the second truth, the first condition is having a capital T truth. So let's run this and see what we get. Select all and run. Good. you can see that the first statement didn't print. Okay, so it's ignored the first one because the first statement is not true. This particular condition is not true. It jumped this statement. It jumped this statement. And now come to the else if. So with the else if statement, once we have the truth, indeed, truth is found in X, it's now come and print out this. Okay, it's now come and print this. Now, if assuming that this condition 2 is not true, it will jump this statement and now come and print out this. So that is how this one works. That's how the if else statements work. Okay, so in fact, you can write as many as if statements that you want. You can write as many as if statements you want. It will check all of them before it will come and print out something else for you. Okay, all right. The next statement, conditional statement that we want to look at is the switch statement. Okay, with the switch statement, the switch statement actually works in such that it gives you give cases. Okay, so first of all, the switch will now, you evaluate the switch and then to check your case 1, case 2, as many as cases that you have, and then now come and execute whatever you want to, you want to execute, okay, your result. So we have it like this. So for example, okay, so let's look at it like this way. So first of all, but it's like, as this particular case is being evaluated, okay, if this particular case is true, it will come and run this code and run out of the loop. If this case is not true, it will move to the next case and go and check if the next case is true. And then if the next case is also true, then will come. But if the next case is also not true, it will move to the follow another case. So it continues like that till it finishes the loop. So it's like we have numerous of cases depending on how you want it. Okay, so if you want as many as cases you have, you can actually specify all of them and it will have to execute all of them for you till it finishes. Okay, so that is how the case works. So let's see something. Let's try something. So we have the switch, statement, and that let's say we have x being assigned, and we use the switch keyword. So you have the switch. So as soon as you click it, it's asking for the object. Okay, the object that I want. Okay, what object do I want? So what object do I want? And the first, I want to give maybe like, so I specify 5. So let me specify 5. And then the first case, my first case, I want to say that I want to specify, maybe I want to print out a particular day in a week. Okay, so let me say that the first one is something like, okay, so let me just say that, let me indicate 1, then I'll say equal to, what do I want to print if it is 1? If the case is indeed 1, what do I want to print? I want to print maybe Monday, and then comma, then I'll come to 2. If it is 2, what do I want to print? I want to print, so Tuesday, comma, then 3. If it is 3, I want to print out Wednesday, then 4. If it is 4, I want to print out Thursday, and then 5, I want to print out Friday 5. Okay, so and I've given it a particular conditions. The case 1 means that, okay, 1, if the statement expression that I've given, if the expression is 1, then come and print out Monday for me. Moves throughout till it identify where the 5 is. So you can see that the result over here is Friday. So as it moves on, as it moves through the cases, it indicates that it realized that, okay, the 5 is actually located here, and what corresponds to the 5, it prints it out, which is Friday. So that is how the switch statement work. Okay, so that is how the switch statement work. Okay, the next we want to look at is the loop. Okay, we want to look at the loop, and for the loop we are going to look at 2 loops. We have the for loops and then the while loop. Okay, so with the for loops, it's the for loops and then the while loops. They are the 2 loops that we mostly use. Okay, so for example, when we are looking at the for loops, we give a particular conditions, and then it's run through all the conditions to check which of the statements that we are giving, all the conditions that we are giving, are they really true? The one that is true, it executes it. Okay, and then if a particular condition is not true, it moves to the next conditions and then try to execute. So you see that a for loop is a repetition control structure that allows you to efficiently write a loop that needs to execute a specific number of times. Okay, so like if you want to execute something for a specific number of times, we use the for loop. Okay, so let's look at some structure. Let's look at the structure of a for loop. So we say for, so we have the for loop. So let's just write example, and then we will give a particular, it's like for, then we give a statement, and then we try to, okay, for those particular conditions, if the condition inside is true, execute a particular statement for me. Okay, so that is how the for loops actually work. So let me give some conditions. Let me write something. Let me say that y equal to, and let me write some alphabets, maybe from alpha capital letters from A to maybe D. Okay, so I'll say that x is equal to, then I'll use the letter function. The letter function here is used to create, okay, so letters. The letters function is used to create alphabets. Okay, to a specific given, and I'll give in the range, and the first one I'll say 1 to 4. Okay, so 1 to 4, that is what I want to print. I want to print it from like A, B, C, D. Okay, so give it from, start from 1 up to 4. Now, unlike Python, we have the R. In R, when we are talking about indexing, it starts from 1 to iterate for me, okay, until the condition is done. So it's like first of all, to create this particular vector. When it creates this particular variable, the y will hold it. And then I'm saying that for I in y, then what I is going to do is that I will go and iterate from this. It will start from here. If it found this, it will print it out, then go back again, like that until it ends. So that is what the for loop. Good. So you can see that it has created it from A, B, C, D. Okay. If I print out y2, it will give me A, B, C, D. Okay. So with that one, it will create it this way. But because I'm using a for loop, it's actually going through it one by one. So it will go the first time and print out the first element that it discovered. And then it will move to the next one and print out the next element as well. Then it will go again and print out another till the condition that I've specified is fulfilled. If the condition complete, if everything is done, then it will break out, it will leave out of the loop. Okay, So that is how we use the for loop. Okay. The next one is the while loop. Okay. With the while loop, it also just repeats. It gives a repetitions of what you do. So the while loop executes the code, the same code, and over and over and over until the stopping condition is met. So if you want to execute a particular thing, the while loop will execute it over and over and over again till a particular condition is met. Now, one thing we should note is that if you write a while loop with and without ending condition, it will run over and it will run without ending. So at any point you are writing a while loop, you should always be cautious of what you are writing, so that the ending condition, you should have a stopping condition. If you don't have a stopping condition, it will run over and over again until you interrupt the listen. You either close or find a way to stop it. So that is how the while loop works. Okay. So let's just look at something. Let's try to repeat. Let's try to write some, maybe. Let's look at something. Let's look at something here. So we have the while loop. So let me write something. Let me just try to write some code. So let me say that v, I'm trying to assign it to a variable, and then inside this particular variable, I'll create a vector, and then so let me say hello math. So hello math. So this is what I've created. Okay. So this is what I've created, and then now I want to use a while loop to run this particular thing. Okay. So let me set a condition to maybe let me try to set a particular condition to a particular something, a stopping condition. Okay. If I don't give a stopping conditions, it will run over and over again. So let me try and give to x plus 1. So I'm giving it an increment. I'm trying to give it an increment over here. So let me give it an increment. So what I'm doing here is that I'm giving it a count, and this particular one. So when it check, first of all, it will check and see, is x less than 10? If x is less than 10, it will print out v. So that is 1. Then it will come down here and come and increase the value of x. Okay. So if it increases the value of x, it will now go back to the loop again and go and check. So let's run it and see what you get. Good. So now it has run for us. It will repeat for us. It will be a repeated loops. We have print this, while this is equal to this, print this for us. Let me check what is wrong. Let me check v. Good. And let me check x. Oh, okay. X is still having Friday inside. So maybe let me just use a different variable. So this should. So this should run for us. Why this is not running? So it's having, we are trying to say that when we have do an increment an increase for us. at any point in time you don't have this particular time, it's supposed to, okay, let me close this particular one and see. Oh, sorry, I've now seen it. This one, we said that t less than 1. Sorry, t less than 1. It's supposed to, we didn't give it as an assignment operator. So let's come back to this place and say x equal to x plus 1. So when we run this, now this should give us a result. So now let me call t over here and see what I get. T is 1, v, good. So this should run. It's still not giving us the result I want. So what is happening? We have the while the condition is x is less than 10, print out v. Okay, so why don't I comment this and then run only this and see what I get. In my environment, wow, so what is happening? So this is how we indicate the while loop. But I think I've made some mistake somewhere. I'm not figuring out the mistake. So we have the unexpected string constants. Okay, let me try this again. So let me see. Have the hello, and then the next one is max. The while loop supposed to run for us. Okay, t, and then we have t, have t. Good. So I literally made a mistake, and the mistake was, you see, one loop called the repeat. Okay, with the repeat loop, it's just like the while loop, but then it just works like the while loop. It also repeats a statement. Okay, but this time around we use a stopping, that is a sequence to stop it. You see that we use a statement to stop it. For example, the break statement to stop it. So let's look at the repeat statement. So I say So repeat statement. So the repeat, for example, so let's assume that here I will assign a value to x, and let me assign 2 to a particular variable. And what I will do is that now I want to use the repeat, so I'll say repeat. So I will say repeat, and I'll open parentheses. And now what do I want to do? I want to print. So print. Okay, I want to print something. So print into brackets. I'm going to print v. So let me just copy the same value over here and then paste it on top of this. Good. So now I want you to print v. So when you print this, what do I want to do? I want you to repeat it, but just print. First of all, you to first print 1, and now I'm now going to do an increment. Okay, so addition, and then you break out. So the break statement is the break I'll specify over here is actually going to stop it from running. So that is what the break statement is doing. So when we run this, so let me clean this before we run the script. So let me run it now. Good. So what it do that it will run it several times until it's met this particular condition. Okay. As soon as x is now become greater than 6, just stop. So you can see it will run 1, 2, 3, 4, 5, 6. So as soon as you get to where x is greater than 6, it will stop, which means that it can't go beyond the 6, even though x will be equal to greater than 6, which will be 7. The 7th one supposed to print, but this break statement has terminated the printing, the repetition. So the break statement has terminated the repetition, so it won't continue again. So that's how we also use the repeat statement. Okay, that's how we also use that of the repeat statement. Equals maybe the character d. If it's got to a character d, then what do I want to do? What I want to do is here that I want you to go next. Okay, so next. So I'll use the next statement. Now once I use the next statement, I will come out from the if statement and I'll say that print. So print I. Okay, so let's clean the over here. Now let's run this and see what we get. Good. So what it's doing is that it will actually run from the top. So the for loop is actually work and run from all the top for me. So when it runs from all the top, it actually starts in the for loop is working. When I is in 8, it will start because we have it works like this. So we have the letters that we specify. We have 1 is to 6, and then it will give us A, B, C, D, E, 1, 2, 3, 4, 5. A, B, C, D, E, F. Okay, so these are the letters that we are supposed to produce. Okay, these are the letters that you are supposed to produce, the 6 of them. So these are the letters that you're supposed to produce. And now we are saying that the for loops, okay, the for loops is actually going to iterate through this. So I say that for I in this, it should print out all of this for me. So it's the in literal sense, what it will be happening, the I will go here. So it will go here, the I will go here. Once the I locates this, it will print it out. Then it will come up again. When it locates this, it will come and print it down. When it comes here, it will print it out. Then the next statement that we specify, the if statement, this particular if statement is now coming to check if I is equal to D, then the next will work. Jump. Okay, so it's like when you come here and then I is equal to D, don't print, just jump. So the next statement here work over here. So the next will over work over here, which is like jump. Okay, so jump over this one. Then you come here, then I will now come here. Come and locate this one. So, and then come and print. And come and locate where, and come and print. Then it will finish. So it's like the next will jump the line that we are specifying. So that is what the next statement does. Okay, so that is what actually is happening over here. It's the next jump. So that's why when you see it, we have A, B, C, the D didn't come, then we go to E and then the F. So that is how the next statement also works. So those are the two statements that we have that we also use, the break and then the next statement. They are the two statements that we always use to jump. Either we use to break or we jump. Okay, all right. So as we continue, let's continue. So the next thing that we want to look at will be function. Okay, we want to look at functions in R. Now there are so many functions in R. For example, R has we have some inbuilt functions, and there are some functions that you can also create yourself. Okay, so you can either create a functions or use an inbuilt function. Okay, so you see that a function is just a set of statements organized together to perform a specific task. So it's just like they actually kind of a statement that we organize together. It's either you organize it together yourself or you use the inbuilt one. Okay, the inbuilt ones are also organized together, and their duty is just to perform a specific task. Okay, their duty is just to perform a specific task. Some of the inbuilt functions is the mean, the average, the square root, and all those. And you can also create your own function as well. Okay, so those are the thing that we have about functions. For example, let's just use some of the inbuilt functions to access our data. So one of the inbuilt functions that we can use is like, for example, so let me create some value over here. So let me say that, let me use the mean. The mean is an inbuilt function. Okay, the mean is an inbuilt function, and let me create a standard random numbers. So let me just say that 23, and then to somewhere like maybe 30, and then when I run it, it will find the mean for me. For you to, if you don't understand a particular function, you don't know the use of that particular function, you just have to type the question mark and type the name of the functions. Once you hit enter, you would find the documentations of that particular functions, the arguments that it takes, and how that particular function works. Okay, so those are the inbuilt functions, and the mean, the average, the sum, the square root are all the inbuilt functions. For example, let's say that I want to sum up some numbers. So sum, and then maybe I want to take a range of some particular numbers and say that 1 to 5. So when I run it, it should sum up all those numbers within that particular range for me. So that is about that. Those are the inbuilt functions. Aside the inbuilt functions, you can also create your own function. Okay, that is what you want to look at. If you want to create your own function to perform a specific task for you. For example, let's assume that you are working, and at a point in time, you want to create a function to do a specific task for yourself. How do you create that particular functions? Okay, those functions are what we call the user-defined function. Those functions are what we call the user-defined functions. The ones that I just specified, the mean, the sum, the average, they are the inbuilt functions. But the user-defined functions are the one that you create yourself. Okay, those ones are the ones that you yourself create. So let's look at them. So we say that, let me give a comment and say, so functions. Okay, so the first one is that we want to create a particular function. Okay, so what we want to create are, let's say that we want to create a function to do some work for us. So let's just think about something. Okay, so let's say that we want to create a function to do some simple tasks for us, and the task that we want to do is that, okay, let's say that okay, let's think about the print out the square of numbers in sequence. Okay, so we have a sequence of numbers and we want to print out the square of all those numbers. So how do we print, how do we do that particular task? Okay, how do we do that particular task? If we give a particular sequence, how do we do that? So let's create a function to do that. And let me see that my function, so this is how we create my function, my func. So my func, and I'll assign it to, and we use the keyword, the function keyword. So I'll say that function, and then the first thing I have to specify is the parameter inside the function. So the parameter that I want to specify inside the functions, and let me just use a word like letter A and put inside the function. So now I'm now going to specify how 1 up to 6. So that is how the series is going to create. So the for loop is saying that, okay, so for I in this particular range from 1 to 6, what do you have to do? Then B will now come and take over. Okay, if I is in this particular range, then B will come and take in charge. Then B will now be equal to I to the power 2. Okay, so once I goes here, for example, if I say that A is equal to 6, then it means that I'm having 1 to 6. Okay, that is my series. My series will now be 1 up to 6. So that is how my series is going to be. My series is actually going to be 1 up to 6. And if my series is 1 up to 6, then I will be moving out, I will be moving in repeatedly. So it will be like my series will now be 1, 2, 3, up to 6. And I will now be moving. Okay, so the first of all, what I will do is that I will move here. When I get to this particular place, it will pass it to B. Okay, it will pass it to B and then do calculation and save it in B. Okay, so it will do calculation and save it in B. So the first calculation you do, will happen over here will now be B is equal to 1 to the power 2. And the answer instantly will go through the print. So the answer will go through the print, which is the B, and then this will be displayed. So the first answer will now be, it will be like 1 to the power 2 will now is 1. So that will be the output. So this output will be instantly displayed. And once the output is displayed, I will now go in. The name is my func. Okay, so my func, and it take only one argument, because inside the function I specify that take only one parameter, which is the A. So let's assume that, let me clean here and give it a new parameter, which will be probably something like 1. Okay, so let me say that the function here, let me open this a bit. So my func, okay, so my func, so when it's asking, you see, as soon as I select that part, as soon as I finish typing the functions, it has written it at the top over here for me that A was inside, showing that it takes only one parameter, which is the A. Okay, because that was what I specified inside the function. Okay, so now what do I want to put inside? Let's say that I want 5. So I put 5 inside. As soon as I click OK, it will run for me. So now let's see. we have 1 up to 5. So it will create a series from 1 to 5. And the series from 1 to 5, it will square each of them. Okay, so let's see. We have 1 to the power 2 is 1. 2 to the power 2 is 4. So it's like that. So this is how it is. So I've created a functions. I said my func, and the argument I give is 5. So the first thing that will happen is that it's going to create a series. The for loop over here, this for loop that I've created, the for loop stayed throughout our tutorial today. We have dealt with a lot of strings, okay, but I've intentionally didn't mention them, most of them. However, when you move on, you can see that we have so many things in quotes, okay, and all those ones are all called strings, okay. So you see that a strings is any character or any written, okay, in quotes, either a single quote or double quote. Once you have them in a quote, I'll treat it as a string. Anything that you write, when it's either a single quote or double quote, I will treat it as a bye-bye.